All right, so this is the continuation of complex numbers. So last time we discussed how to add and subtract, how to simplify radicals with an I. We talked about how to also graph them, okay? So here we are going to be multiplying complex numbers, and then we're going to be solving, all right? So it says here for multiplying complex numbers, to multiply complex numbers, use the distributive property or the FOIL method, just as you do when multiplying real numbers or algebraic expressions. Okay, and just a reminder that I is the square root of -1, if you have forgotten. So I equals the square root of -1. But over here for our chart, I just wanted to make sure you remember that I is I and that I squared is -1. Those are two important concepts you definitely need to know. All right, so for the first example, it says multiplying complex numbers, multiply, write the answer in standard form. So once again, standard form, if you have forgotten, is A plus BI. All right, so let's go ahead and solve these here. So for the first one, letter A, we're going to distribute that 4i. So 4i times -6 is going to be -24i. 4i times I is 4i squared. Now, standard form is only a real plus an imaginary, and I to the first power. This has a squared here. So I'm going to work this out completely. So -24 plus 4 times, we know that I squared is actually -1. So instead of writing I squared, I'm going to put -1. And last, oh, sorry, this is I. And last, we're going to rewrite it. So -24i minus 4. Make sure it's in standard form, real plus imaginary. The real is second, so we're going to rewrite this one last time. -4 minus 24i. And this is my final answer in standard form. All right, taking a look at the next one. This one, we have two binomials, so we're going to FOIL it or double distribute. So I'm going to start with the 9. 9 times -4 is -36 or -36. 9 times 7i is +63i. Now I'll distribute the -2i. So -2i times -4 is +8i. And -2i plus 7i is -14i squared. All right, from here, we're going to combine our like terms. So it's going to be -36. 63i plus 8i is going to be +71i. And now we already know that this is going to be a -1. So in your head, you could actually do -14 times -1 and get +14 if you choose to do so, okay? But for right now, I'm not going to skip that. When I get to the next ones, maybe I will, but I'm showing you can already do that if you have the concept down. If not, -14 times, we know that I squared is -1, -36 plus 71i, +14, and last we combine our like terms and make sure we put it in standard form. So we have a -36 plus a 14, which is going to be -22 plus 71i, and that is now in standard form. All right, moving on to complex solutions in zero. So solving quadratic equations. So we're going to solve here for x. And if you recall, when we solve these, we do PEMDAS backwards, so SADMAP. Okay, so let's go ahead and work through this first one here. So to isolate x squared, I'm going to first subtract 4. So I'm looking for addition or subtraction. So I'm going to subtract the 4. And that gives me x squared is equal to -4 or -4. So I did that. Now I'm looking for multiplication division, which I don't have, but I do have an exponent, and it's a square. So to remove that, we put a square root. Don't forget to put plus or minus. And now we have x equals plus or minus. Now I see this minus sign right there in the inside of a radical, so automatically I'm factoring out an I. Now I want you to notice the I is right next to the radical, okay? It's not on the other side of the plus or minus, it's right next to the radical. So plus or minus I square root of 4. And hopefully you know plus or minus that the square root of 4 is 2, so that's going to be 2i. So x equals plus or minus 2i. All right, for the next one, we're going to solve it in pretty much the same manner. We look for addition or subtraction, and we have a -11, so we're going to add 11 to both sides. So that gives us 2x squared is equal to minus or -36. we do have multiplication and division. We have a 2 times x squared, so we're going to divide both sides by that 2. And that's going to give us x squared is equal to negative 18. Our exponent is a square, so we're going to take the square root of both sides to remove it. Don't forget to put your plus or minus. And that's going to give me x equals plus or minus. We see this minus sign in the inside of the radical, so we factor out an I, square root of 18. Okay, every time we see that number like 18, we inside a radical, we're going to have to try to simplify that. So off to the side. So the smallest prime that goes into 18 is 2, 9 times. 3 goes into 9 3 times, and 3 goes into itself once. So when I write my answer, x equals plus or minus, I know the I already said goes next to the radical. I'm looking for pairs, so I see a pair of 3's, and that goes right here, multiplying to the I. And then my singles go back in. 2 times 1 is 2. And last but not least, I'm going to write it a little bit nicer, even though that is acceptable. Plus or minus 3i square root of 2. All right. Now we have example 3, which is finding zeros. So finding zeros, complex solution zeros, these are the same thing. They're both solving, but it's just a different way that you can possibly see it. All right, for this one here, in order to find the zeros, we have to change this y, f of x is y, to 0. So we're going to write 4x squared plus 20 is equal to 0. Okay. So first, add or subtract. So we're going to subtract this 20 to both sides. So we get 4x squared equals to negative 20. Now we're going to multiply, divide. So we're going to divide by the 4 here. So x squared equals to negative 5. Now we're going to do our exponents. We get rid of the square by taking the square root. Don't forget to put plus or minus immediately. And now we see we have this negative in here, so x equals plus or minus I on the outside right next to the square root and 5. 5 is a prime number, so we cannot simplify it any further. This will be our final answer. All right, and the last thing I could possibly make you do is to graph these solutions, like on a complex plane. Like real axis is horizontal, imaginary is vertical, but you might want to reflect on your notes for that. That's it.